Good evening, everyone. Welcome to the aquarium. I'm Jerry Schubel, president of the aquarium. I want to welcome all of you who are here in person and all of you who are watching remotely. For those of you in the theater, we request that you put your cell phones on vibrate or turn them off completely and refrain from texting for the next hour. I want to thank our lecture sponsors, Gazette Newspapers and Courtyard Marriott. Tonight, it's a pleasure to welcome Dr. Ester Quintana. She's from the New England Aquarium, and she's going to discuss right whales and their complex relationships with humans. The exact title is on the screen. Dr. Quintana grew up in Guatemala. She came to the United States after receiving her undergraduate education, and she attended university in Florida. She got her master's degree in zoology from the University of Florida, and she got her PhD in biological oceanography from the University of South Florida's College of Marine Sciences. She's the lead scientist of the marine mammal surveys conducted in the offshore waters of Martha's Vineyard and Nantucket, Massachusetts. She's also studied social behavior and communications among marine mammals, including bottlenose dolphins and humpback whales. She's worked on management plans for manatees, including the plan for the West Indian manatee that was developed for the United Nations Environmental Program. She's a research scientist at the Anderson Cabot Center for Ocean Life at the New England Aquarium. Please join me in welcoming Dr. Ester Quintana.
Well, thank you for the nice introduction, and thank you for the invitation. This is my first time at the aquarium, and I'm very excited to be here, and I'm looking forward to this presentation. As Jerry said, I'm a scientist at the New England Aquarium, and specifically I work at the Anderson Cabot Center for Ocean Life. But the accent always reveals that I'm not from the US, so I just want to tell you a little bit about my origins. So as Jerry pointed out, I was born in Guatemala, and I did all my undergraduate work there. Since I was a child, I had a deep connection for the environment and for animals, and I always think that my mother is really the person responsible for that, because she always created not so much in words but in actions. We always saw that she was very respectful of any pet we had in the house and of any plants or anything. So I just had a deep appreciation for the environment immediately. And growing up, I saw a lot of documentaries by Jacques Cousteau. Many of you probably know who Jacques Cousteau is. And I just wanted to be a marine biologist just because of Jacques Cousteau. But I think that the biggest impression was probably some scenes, and I still have it in my head right now, the scenes of whales being hunted, like by whaling ships. And as a child, I just wanted to do something, something about it. I didn't know what that was going to look like, but I had to do something about this. And when I learned that I could study whales and make a career out of it, I was like, that's it. That's where I need to go. And so I have worked with several species. I have worked with humpback whales, manatees. Now I'm working with right whales. I have traveled throughout the Americas doing different types of work, and I was very lucky and blessed to go to Antarctica and on a research expedition that was looking at the effects of climate change. And I live in Florida for a long time, for about 20 years, and I'm living in Boston. I'm still getting used to the weather down there, or up there, I guess. But life takes you in different places, and that's the exciting thing. So this is the general outline of my presentation. So I'm going to discuss some general facts about right whales to give you a sense of the species that we're talking about. Then we are going to briefly look at the origins of population in crisis, and then describe how we identify right whales in the field. We're also going to talk about the current population size, status, trends in mortality, health assessment in right whales. That is quite important. Problems that they have with entanglement, ship strikes, and climate change, which is a big topic right now. And of course, there's going to be time for questions. So when we talked about right whales, so we used one word to describe really 3 different species. And the 3 species have the same genus. That's the Eubalaena. Eubalaena means true whale. And there is the North Pacific right whale, the North Atlantic right whale, and the Southern right whale. And as you can see from that figure, they look relatively similar. And genetically, they are different, but all of them are mostly black. Sometimes there are some irregular white ventral patches, as you can see especially in the Southern Hemisphere right whales. Calves might sometimes be lighter color as well. There's no dorsal fin, like typical of like dolphins. I'm sure that you have seen that. The flukes are actually very broad, and adults are typically between 13 to 16 meters. But the North Pacific right whales are a little bit bigger. They can be up to 18 meters long. I'm sorry, I keep going to the pressing the wrong key here. There we go. So this figure here, I put it just to give you a sense for how right whales compare to other species of whales. It felt like home. And historically, right whales have occupied all oceans, and the different species are found in different parts. So the North Atlantic right whale, as the word suggests, is found in the North Atlantic. Then the Australis is found mainly in the Southern Hemisphere. It has this circumference around the Antarctica. And then the North Pacific right whale is close to Japan. So the populations of the 3 species are a little bit different, and that's actually very interesting. So in the Southern Hemisphere, right whales are estimated to be about 10,000. So that's a really high number. In the North Pacific, surveys have not been conducted to really estimate population size, and the best guesstimate is somewhere between a dozen animals to 600. And you heard me well, 12 to 600. So that basically we don't know how many there are. When you have that range, it doesn't really give you a good story. And in the case of the North Atlantic, on the eastern side of the North Atlantic, the stock of right whales is probably extinct. And on the western side, we believe that there are just over 400 left. And I'll talk more about that in a minute. So the question is, why are right whales so rare? And we say that the global assault on right whales began over thousands of years ago in Europe. So hunting right whales became the model for all further whaling enterprises. And in fact, right whales were named by whalers who identified them as the right whale to hunt, because when they die, they float. And it was easy for whalers to basically do anything with the body that they needed to do at the moment. And so it was just the right whale to hunt at that time. Of course, it was not the only one, but other species have different common names. So whaling started in the North Atlantic, then it moved to the South Atlantic, Indian Ocean, and it went back north to the North Pacific. And in retrospective, whaling was one of the most extensive and prolonged campaigns of wildlife exploration or exploitation, in all human history. That's how it is characterized. There was, a lot of animals were killed in a very short period of time. I hope I'm going to press the right, yes. So this map shows the general locations of whale fisheries that took right whales in the North Atlantic only. And the icons that you see on the slide shows the nature of the technologies used at that time. And basically, if you look at the period between 1634 and 1951, we basically believe that about 5,500 right whales were killed. And it is also believed that the population of right whales at that time was about 10,000. So basically, more than half of the right whales that were available at that time were extracted from the population, at least. This picture that you see here is actually the last right whale that was killed in the United States. And this happened on March 24, 1935. And it says EG 1045, because that's the ID, or that used to be the ID of that animal. So that day, off the west coast of St. Augustine, the story goes that a sport fishing vessel spotted this mom and calf that were resting at the surface. And they decided that they wanted to pursue the calf. And using high-power rifles, the men shot more than 100 rounds into the mother in an attempt to separate the mother from the calf. But she didn't leave the calf. And it just happened that a news reporter from the New York Herald Tribune was on board, and so he took many pictures of the event and he documented what happened that day. And over a period of 8 hours, they were trying to separate mom and calf until the calf finally died, and mom left. And they brought the calf to shore, and they did whatever they had to do. So that happened in 1935. In 1959, two scientists from Woods Hole Oceanographic Institute spotted a right whale off Cape Cod Bay, and they took pictures of that animal. Many years later, one of the people in our staff matched that right whale sighted in '59 to the mother sighted in 1935. And the same whale was actually photographed again in 1980, 85, 92, and then in 95, which is 60 years after she was first sighted with a calf, she was photographed with a large propeller wound cutting deeply into the side of her head, and she was never seen again. So what is interesting about that story is that female was never sighted with a calf after 1935. And some people think that was probably because the event was so dramatic that she wasn't able to have more calves, or all the wounds that she received were very severe, so then she was unable to recover. So with the story, you might wonder, how do we know that this whale was who we said it was? So basically, right whales are individually identified by the unique pattern of callosities in their head. And you might wonder, well, what are callosities? So there are some pictures here of 3 animals that show, the first 2 show the callosities on the upper side of the head, and then the last one on the right shows the callosities above the eye. So here are a couple of more pictures. So basically, let's start with the head. The head in right whales is relatively large. It's about a quarter to 1/4 of the body length. The upper jaw, as you notice here, is somewhat arched. So at times, it almost looks like the whale is upside down when it's not. But the callosities are irregular patches of keratinized tissue, which are inhabited by dense populations. and in front of and behind the blowholes. Most sources refer to the whale lice as parasites, but when we use the word parasite, implies that there is a negative effect. And although we know that cyamids are eating the flesh of the whales, they are not really causing any damage to it. So they're just there, but there's no negative effect as far as we can tell. So the term parasite is a little bit misleading. So this, the callosities, as you can see here, let me see if I can point it. So here you can see the callosities, and there are some cyamids. Hopefully you can see that they look a little bit orangey, and they're quite small, and here there are more. So those callosities and the callosity pattern is not fully developed and colonized by cyamids until the whales are a few months old. But they are very unique, and that unique pattern allows us to identify right whales from each other. So those are natural markings that in some way has opened a world of opportunities of knowledge for scientists. So currently, right whales are photographed on an annual basis by scientists throughout the east coast of the United States. And all the photos that are taken are sent to what we now call the North Atlantic Right Whale Catalog that the New England Aquarium manages. And that's really it's a very large catalog. As the slide says here, it's composed of over 100,000 photos, slides, and images. It really is a well of knowledge that allows you to answer very interesting questions about the species. There are about 734 right whales in the catalog. Not all of them are alive. That's just the number of IDs available. So usually what you do is for every right whale that is in the catalog, you create a composite like the one you see on top. So this is the composite of this particular right whale, and this is the one of this right whale here. And you can see that they are very, very unique patterns. So every time that you matching, you have to go back to the original composite to figure out whether you're looking at the same animal or not. And people who do this, we have a team of, like 8, 9 people that are only dedicated to do all the photo ID of right whales for the program, because we receive photos from everywhere, not only in the US, but Canada. And they know the whales really well. So it's a really unique tool to answer different kinds of questions. So one of the things that you can do with this information is to do something that is called a mark recapture analysis that allows you to estimate population size. So the last formal population size of right whales in the North Atlantic was 458 right whales. But I'm giving you that number now, but I'm also going to tell you that that number doesn't include the animals that died last year and this year, and I'm going to get to that later in the presentation. But one thing we know for sure on several independent population models is that the population of right whales has been declining, and there are different reasons for that I will also address in a minute. Other information that we can get from photo ID, from something that we call photo identification or photo ID, is distribution patterns, movement associations. We can identify habitats that are important for right whales. We can count how many calves are born on a given year and how that calf develops or when it dies. You can also study entanglements or ship strikes. So basically, you can do a lot of things. If you know the idea of the whales, you can answer a lot of questions about the population. So one of the things we have noticed is that the distribution of right whales seems to be shifting, seems to be changing around, especially 2011. And we see this more in what we call the critical habitats. So these are habitats that right whales are known to use on an annual basis. So the first one in the list is the Bay of Fundy, Rosway Basin, Great Side Channel. Those are all south in the map. I tried to mark them with the number 1. And then the southeastern U.S. refers to Florida and Georgia. So the number of right whales that we are seeing there has declined in comparison to previous decades. On the other hand, places like Cape Cod Bay actually has a higher number of sightings of right whales. And I don't know if you saw the news, read the news in 2017, where there were over 200 right whales spotted one day. That's a really high count. It's really exciting, but it's a really high count. And then other places where, like I do a lot of my work south of Nantucket and Martha's Vineyard, we are seeing that there seems to be a higher number of right whales. But having said that, it's also true that the field effort there has increased, and so perhaps what we are calling now a higher number of right whales might be just a reflect of the fact that there is more research effort that is being conducted there. Other places like the Gulf of St. Lawrence also has more sightings of right whales. So, but the point here is that there's something in the environment that is changing because they are not being seen in the same numbers at those locations. So one thing that might not be clear from the previous map is that these animals are migrating up and down the coast. So in the fall and winter, females with calves and some juveniles and some male adults spend their time in the warm weather. They go to Florida and Georgia. If I will do that, I mean, even if I wasn't pregnant, I would still go there. But others actually spend most of the time in places like Cape Cod Bay and in George Bank. And then they go back, and they go north to Rosway Basin and the Bay of Fundy, and then the cycle repeats and they come down. So as they move, and that's a really long stretch of coast, they encounter all kinds of things. You know, there's a lot of shipping traffic in that place. Fishing gear is all over the place. So these animals are really dealing with a very unique situation. This right whale here was actually killed by a ship in Florida, just outside of Jacksonville, and ship strikes are a problem. And you know, the right whale population is in trouble. And as we discussed before, part of the problem is that they were severely impacted by whaling. But the issue is that despite the introduction of international regulations protecting them from commercial whaling, the North Atlantic right whale has failed to recover. And that seems to be due to several factors, which I'm going to tell you about in a minute. So over the last decades, approximately 50% of all deaths are from collisions with ships and entanglements in fishing gear. The percentage of deaths from human activity is increasing, and this graph shows right whale mortalities by cause since 1970. A total of 123 mortalities were detected. And that's important. The detection is only the ones we see, but there are probably more than we don't see. So 40 of those were either not retrieved or were too far decomposed to determine the cause of death. So if we exclude those 40 cases, we have 83 animals for which it was possible to determine the cause of death. And of those, if you look at this pie chart, 43% were ship strikes, 29 were death from entanglements, and the remaining 28 was natural mortality of neonates. So this is a little bit alarming, but something that is important to point out is that an increase in deaths could also be related to the fact that the population at that point, in some point, in part of this period of time, was actually increasing. And also, there's more awareness. So people might call and say, you know, there's a dead right whale of Nantucket, of Cape Cod, and then those deaths can be recorded. In the past, that didn't happen. But it's also true that the rates are also increasing. So all the combination of factors makes some of this a little bit messy to interpret. But this is a different time frame, and these are not counts. These are statistical estimates. So in the year 2000 to the present, this is what the data looks like. So animals are presumed, in the case of right whales, Animals are presumed dead if they have disappeared from the sighting record for more than 6 years. Very few animals that are in this category have ever seen again. So this is actually a very reliable indicator. So using that, basically, the assumption is that there are 139 presumed dead right whales. Of those, actually 68 are known. So basically, twice as many right whales have died as were detected. And if that holds true, that means that last year, at least 45 right whales died, both in the United States and Canada. So I'm telling you 45 is the number that the model gives us. But if we look at the animals that were actually detected, then the number is quite, it's different, so it's lower. So in 2017 and 2018, deaths are considered to be part of something that we call the unusual mortality event. And that is defined as a stranding that is unexpected. It involves a significant number of animals in that population, and it requires an immediate response. So in 2017, as you can see in this graph, there was a total of 17 confirmed dead right whales, 12 in Canada, and 5 in the United States. And to date, in 2018, only 2 whales have stranded in the United States. So the causes of death were determined as blunt force trauma for 5 of the animals, chronic entanglement for 1, and possible entanglement for another 1. And 10 causes of death have not been determined. So most of these deaths happen in Canada, and the Canadian government was relatively quick to respond to this event, and they actually established mitigation measures to help reduce vessel speed. And this mainly happened in the Gulf of St. Lawrence, where a lot of these animals were found. And they also enacted fishery closures to help reduce future entanglements. And this is just a map to show you the locations where this happens. So here, this is the Gulf of St. Lawrence, and that's just showing the New England waters, and one of the carcasses was offshore. So since we went over this information, we can go back to this population estimate, and we said that originally we thought that there were about 458 right whales. But if we deduct the 2017 and 2018 deaths, then we only have 439 right whales that were detected to die. But again, we are not detecting all the animals that die. It is impossible to do that with a species that is offshore, unless the carcass comes, closer and people see it. So we are estimated that, as I said before, that the number of deaths just in 2017 was 45 right whales. So if we subtract that number from 458, we have 413 right whales. But the truth is that it doesn't matter if it's 439, 420, 415, 410. The point is that there are just over 400 right whales alive at this point, and that's a really low number. So the other thing that is a little bit disturbing is that between 1990 and 2010, the abundance of right whales actually increased from about 270 in 1990 to 482 in 2010. And since then, their abundance has declined every year. And now we are in the situation where there are just over 400. And if you look at that graph more closely and look at gender differences, then you see that most of this decline appears to be related to a decline of adult females in the population. So they were estimated at 200 in 2010 and 186 in 2015. And on top of that, there is the known deaths of at least 7 females in 2017-18. So the gap between the genders is widening. And right now, the sex ratio is 1.5 males per females. So the question is, what is it about females that makes them more vulnerable to mortalities than males? And one way to address or to answer that question is to look at potential differences in health status. So assessing the health of any wild whale or dolphin is difficult because you don't see them. You don't see the entire surface. The entire body at the surface for long periods of time. And yet, it's possible to actually detect changes in the body composition that could relate or correspond to physiological changes, known changes in the animal. So this is not a right whale, it's a dolphin, but I'm just going to use this now as an example just to illustrate something. So for example, the loss of fat reserves due to disease, so starvation is something that can be evaluated visually. And this figure shows the body condition scoring for dolphins. So you can see that 1 is emaciated, 3 is ideal or average, and 5 is obese. I don't think there are obese dolphins in the wild. This might be for dolphins in captivity, if anything, but it's just the point, it just gives you a comparison. But in the wild, a dolphin that is emaciated has a concave depression in its head, something that we call peanut head because it's like a peanut. You might see the reefs. So there are some things that are very obvious and indicators of bad health condition. In the case of right whales, our team actually developed 4 visual head assessment parameters that are now widely used and accepted. And they include the body condition, skin color, blowhole cyametes, remember those are the whale eyes, and any rare marks in front of the blowholes that can be photographed during the standardized surveys that we conduct by boat and by air. So all of these are scored on a numerical scale, and lower scores indicate good condition. And I'm not going to go over each of these in detail, but I just wanted to show you some examples just to so you get a feeling for what this looks like. So on the left, you can see the scores for body condition, 1, 2, and 3. So in the case of 1, the whale has a flat or rounded back, as you can see in the top. So that's a whale in good health condition. But then this one here has this marked concavity, and that's definitely a sign of poor condition. This other figure represents examples of blowhole with cyametes. So a score of 1 means that that animal has few or none, and a score of 2 that it has many. And too many cyametes could also be an indication of poor health. So in the case, let's go back to females. In the case of females, if we compare the health scores of females during calving and non-calving years, we found that females were significantly thinner in calving years in the year after calving compared with the year before calving, showing that changes in body composition or condition occur during the reproductive cycle. In addition to that, a female that has a calf is more likely, is more likely to spend time at the surface taking care of the calf because the calves are not deep divers. And what that means is that they are going to expose themselves more to any ship strikes. So those two things together are not good things for females. So the same study showed that lacting and post-weaning females have lower health scores than other demographic groups. And the overall health of a female relates to where she is in her calving cycle. So for example, a lacting female, as shown in that graph, is going to have lower scores than pregnant females. And that's the same thing that we see in other mammals. This graph compares the health scores of females that were available to calf, successfully got pregnant, and calves, and that's in green color, and those that didn't, and that's in orange. And so the females that got pregnant had a mean health score of 75, and those that didn't produce a calf had a score of 73. So it's a really small difference, but it's significant, suggesting that any small changes in the female health might influence its reproductive success. Females that have a health score that is below 67 are likely not to reproduce. So that's a really good indication of of what to expect on a given year. And just to put it in context, the top panel here shows the number of calves born into the population each year, and the bottom panel shows estimates of population level over 25 years. And the shaded rectangles indicate periods of reduced calving rates. And what is interesting is that the periods of larger decrease in fecundity correspond to the lower average population health. So calving is telling you a story about what the species is experiencing. The other problem for females, and for males, anyone in the population, is entanglement. So over 82%, it's a really high number, 82% of North Atlantic right whales had been entangled in fishing gear at some time in their lives. In most cases, more than one time. Entanglements happen between 30 and 60 times per year for the species. And an animal that was seriously entangled, based on this health score that I presented to you previously, actually has shown a decline in health even a full year after the entanglement. So basically, if that animal is entangled for a year, it's going to take another year for that animal to recover. So even if a female survives this event, it is possible that she might not be able to produce a calf in the near future. So this graph shows the annual right whale kills from human activity. The increasing mortalities is statistically significant, but the major cause has changed. So until 2009, 44 of the diagnosed right whale mortalities were vessel strikes, and 35% were entanglements. But after 2010, 50% were vessel strike, and 85 were entanglements. So there's a shift in causes. And that's relevant for females with calves. So given that 83% of right whales had been entangled, there is likely a substantial contribution to poor calving rates for the lasting effects of entanglements on females. And as you can see there, calving is highly variable, but it has recently declined, showing that additional factors are contributing to this. We didn't have, no calves were sighted this year. I don't know if you heard that in the news. I was a little bit, it was worrisome, but we'll see what they do next year. So, there could be different explanations. It could be the effects of entanglement or some limited or shifting prey resources in the area. Another concern is what percentage of females are available for calving and whether that changes over time. So this graph is a little bit busy, but the main points here are that the number of reproductive females has been increasing over time, and that's the yellow line in this figure. So the number of reproductive females has increased, but then the percentage of females that are having calves have declined. So now right whales remain reproductively active for at least 40 years. So if we can eliminate any human causes of reproductive failure, we expect to see a rebound in calf production. The issue with entanglements is very complicated because it's a transboundary issue. These are animals that are migrating between the US and Canada year-round. Fishermen have tended to point fingers at someone else, but this is not about pointing the finger to anyone. This is an issue that is affecting right whales. And if there is rope in the water column, that means that it's going to affect the species. And the reason I put this map here is to illustrate why determining the location is so hard. So in this particular figure, the original entanglement locations are shown in green. So they're here, and then the rest of the locations shows where that animals were sighted. So basically, we don't necessarily know at a given time where entanglement happened and how it can be prevented. So the measurements have to be at times very, very general. But the rope is the problem in this case. So stronger ropes with heavy gear are more likely to injure and kill right whales. but wicker ropes will entangle and injure them injure them as well. This animation, I just wanted to, let's see if I can play it. I just wanted to show you how we, oops, maybe not. Let's see if I, sorry, I'm getting used to this Mac here. Here we go. So this is just to illustrate an entanglement event. So marine mammals live in a habitat that is three-dimensional, and anything that interferes with the free passage is going to have an effect on them. So here you can see that there are a lot of ropes in that area. So if the animals, and a lot of this water is turbid, so if the animals cannot see them, they're likely to get entangled. Some studies have, here we go, so in that case, the fluke gets, the flipper, yeah, so this is, these are big animals, so it's just super entangled right there. And at times, they're going to drag that gear literally from one country to the other, and even vice versa. This whole issue is very complex, and there is a team within our program that only studies this. So this is not an area of expertise for me, but if this is something that you're interested in, I can definitely put you in contact with those people. They are doing currently a lot of experiments to try to use ropeless fishing gear and see if that could help to reduce the entanglement rates. But it's a complex issue because it requires the participation of fishermen that might or not be willing to do it. So some of the reduction options that are included here include the closure in high-risk areas, especially when right whales are present, and that's what Canada did last year, or use wick ropes, or seeking ground lines. Even changing the color of the rope could be a solution, because right whales can actually see red and orange color better. And as I said to you, what we're hoping is that in the long term, ropeless fishing becomes the way to go. It is expensive and it's going to require regulation, but if we want to save right whales, that's what it is required. And last year in 2017, there were 10 active entanglements, and they're called active because right whales didn't die; they just were entangled. And in some cases, there's a team at the Center for Coastal Studies who specializes in trying to disentangle right whales and humpbacks, for that matter. No vessel strikes had been reported for many years, so that's actually a good thing. And part of it is that both the U.S. and Canada have changed shipping lanes, and Canada actually led the way on this effort, and they did it in the Bay of Fundy in the early 2000s. And the other place where this happened is actually near where I live in Boston, where this is Cape Cod Bay. Boston is right here. And all the dots that are represented in the figure are sightings of right whales. And you see here that there's a high concentration of right whale sightings here. So it used to be that the shipping lanes were right on the track of where the right whales were. So the lanes were moved just by a few miles, but it was enough that it made a difference. And we also have IFAN developed the Whale app, and that's a free app that you can download and report sightings of right whales and other species, and the information goes directly to shipping vessels to alert them of the presence of any of those species, and in theory they can be more mindful when they're traveling, and so to prevent any strikes. So the last point is climate change. I know that people have questions about climate change and the effects that has on marine mammals. This is something that is hard to study in marine mammals because these are species that are long-lived. So you have to study them for many years to realize that they actually were affected or not. But having said that, we know that right whales live in one of the fastest warming pieces of the ocean in the planet. That's the Gulf of Maine, which is one of the main critical habitats. So in the whole region from North Carolina to Iceland and northward, that is represented in this figure, sea surface temperatures are increasing, and mainly in this area in the Gulf of Maine. So what we're seeing also in the Gulf of Maine, this is a graph, number of sightings and number of right whales spotted. You can see that is declining. There are a few sightings, but not as many that coincide with this effect. So right whales are moving, and we don't know if it's directly related to the change of water temperature, or maybe it's a change in what their prey is doing. That's probably what is really happening. So this right whales eat copepod. They are really small. They are the size of a grain of rice, and they are sensitive to water temperature. So it's possible that they are, the prey are now finding areas that are new, and that's where right whales are going. So if you don't find them in one place, there has to be somewhere else. But these are areas that are normally or typically surveyed, so finding them there is going to be more difficult. So it's tough being a right whale these days. And that's, I'm putting it in Miley. And I selected this figure to illustrate that, they are being affected by so many environmental factors. And if right whales are threatened with extinction, it's not from a lack of grit. They are actually very persistent. As you can see, their population bounced, then it recovers some, and now it's down again. And we hope that they will recover, and that's why this research is happening. And they're threatened with extinction because their home, which is includes all the coastline from the U.S. to Canada, is one of the most human-modified habitats in the planet. There's a lot of ship traffic that happens there, fishing gear that they have to deal with on a daily basis, and it's probably a difficult life. These are animals that, were hunted for many years, and now they have to deal with other things that we humans are doing to them. So I know that you're probably thinking, okay, what do I, is there something that I can do to help? And I have a list here of very simple things that you can do, and all of them can contribute in different ways. So I know that we are now in California, so we are on the other coast right now, and right whales are on the other side. So you might think, well, they are on their side, so that means that there's nothing I can do. But I mean, if you are interested in this species, something that you could do is sponsor a right whale, and that happens through the aquarium. And so the money that we of that program helps with conservation initiatives for the species. You can also do something similar with other species on the West Coast. Currently there are many species of marine mammals that need our help. Right whales are not the only ones in this situation. So you can pick other species if you prefer one of the ones that are near California. I always say that your daily actions make a difference, and I really mean this. Like everything that we do on a daily basis has an impact on the environment. And it might not have an impact directly on marine mammals, but it has an impact on another species. All the species right now in the planet need our help. So things like the products you buy, the use or not of plastic bags, everything has an impact. And sometimes making those changes take time. So please don't think that one person cannot make a difference, because just look at the current political environment. One person makes a difference. Like it's just really, you just have to, don't give up. Another thing that I was thinking about this the other day, because we had a researcher from Argentina that came to the aquarium, and someone was asking her about whether she has a website that talks about her research, and she was like, no, we don't have a website because I don't have the money to put one up. And I was thinking, well, I'm sure that there's someone somewhere in the US or someone in this planet that will be more than willing to volunteer their time to create that website that she needs. So volunteering your skills could be another way to help directly. to become involved. I think that's actually, and there are many, I'm just giving you one example, but there are many other examples of things that you can do for people who are directly in the field that will have a great impact. Say participate in coastal cleanups. I know that the aquarium had one recently. That's always very, very welcome because there's a lot of trash in the ocean that is affecting not only marine mammals, but sea turtles. Stay informed. I think that's very important. And there are many ways to do that. So, I suggest that you follow in Facebook, Twitter, Instagram, or, all the social media outlets, any of the institutions that are working on causes that you care about. I also wanted to tell you about this thing called Our Daily Planet. This is daily. They send daily morning emails from Monday to Friday with the summary of the main environmental news of that week. And this is really it's really well done, and I highly recommend it. And lastly, vote. Because the environment, I can be here and telling you a really good story and all, but at the end, a lot of this depends on whether there's, we are in the right political environment to save the environment and to save the species. So whoever we select as our representatives can make a big impact. And you know that we have elections coming up, so please vote and vote for people who care, about saving the species, saving the environment. Oh, I was going to say that this is one of the right whales that is in our sponsorship program. It's called Aphrodisiac because her callosity pattern it looks like a heart shape at times, and sometimes it's not very clear, but there are the other right whales that you can adopt. So those are some suggestions, and if you have more, you can share them with us during the period of questions. So actually, I think that's actually my last slide. So thank you, and if you have questions, I'm happy to answer them.
Thank you, Esther, for a great talk. So it's tough to be a right whale, and there's a proposal to create a fairly large wind farm off Nantucket and Martha's Vineyard, and that's an area where a lot of these right whales gather. Are you worried at all about the sound that will be associated with the construction of the wind farm? And they're fairly noisy even once constructed.
Yes, so this particular area south of the islands has been designated for offshore wind development. And on one hand, it's great because these are renewable resources and we are in favor of those. But on the other hand, we don't fully understand the effect that could have on marine mammals, especially on right whales. This is going to be one of the first experiments on that. There's a small wind farm off Rhode Island. There are actually 5 towers, and they found that at that point that the way they did the construction, they were able to reduce the sound production at that point. In the case of this particular location, there's consultation with the group that is working there, that's including me and other people, to outline mitigation procedures to do that. So one of the things that we are proposing is that the construction happens at periods of time where right whales are not present. So that means from like June to December or November. That would be a time where it would be better if they're willing to do that. It will be better for the construction to happen because there are very, very few, maybe 1 or 2 right whales in the area. So that would be one way. Having said that, we really don't know. We just don't know if anything, if it can have a long-term effect.
Okay, who has a question or comment? Raise your hand, and I got one here, and then Linda will get one over there.
I have a regular question, but on your point, once the wind farm is built, is there a vibration that takes place? Is the
Some, but it's primarily during the construction. And even in the North Sea, they've been putting caissons around some of these when you're doing the filing to reduce the noise.
Okay, a question. Early on in the lecture, very nice lecture, by the way.
Thank you.
You had a picture of the globe, and you had the northern whales and the southern whales. The southern whales were a continuous band, and the northern whales had a break in mid-Atlantic.
Yes.
Is that because of decrease of population, or historically has that ever been filled?
It's a little bit of both because, so this is the slide you're talking about, is that right? So this is the break that you're referring to?
Yeah.
Right here, yeah. So right now that's a natural break, but some of the right whales that we have, a couple of the right whales that we have seen in the western North Atlantic have been recently spotted on the other side, but they are not part of that stock. They are on the western side. So originally, we think that there was no gap in between, and because of hunting and whaling, that decreased the amount of right whales in that area. But this is now the natural break that exists.
That's an easy hunting grounds out of the whaling ports on the East Coast.
Yep.
I had two questions. The first one is, what is the gestation period of the right whale, and also the period from when birth to when the whale leaves its mother?
For both, it's about a year.
Total?
Mm-hmm. Oh, total 2 years.
2 years.
1 year, one
And
year
then-
each. Mm-hmm.
Secondly, you've talked about shipping and fishing as the seemingly most important risks for the right whales. So in the case of whaling, government regulation and pressure essentially started to regulate whaling and helped. Is there any hope that our government and or the Canadian government can do something about shipping and fishing to impact the whales?
So in terms of shipping, as I mentioned during the presentation, some of that has been regulated because I believe that in most of the ports of the United States on the East Coast, the ships have to slow down to 10 knots within 20 nautical miles of the port. And by doing that, that decreases the chances that they're going to hit any animals in that area. That's the first thing. The second thing is that for right whales, I don't think that's true for other species, but for right whales, in areas where there are more than, I want to say that is 8 or 10 right whales, ships are, it's suggested, it's not a regulation, but it's suggested that they reduce their speed to 10, and that happens actually south of Nantucket and Martha's Vineyard. When every time that we have a group of animals, then the ships are supposed to slow down. It's not mandatory. That's part of the problem, but people are aware, and especially in New England, it's always in the news. If you have a large group of right whales, it's in the news that just to make it create some awareness for people to actually slow down. So that's the two ways that is happening in the U.S. In Canada, they did change the shipping lanes in the Bay of Fundy, and that's it's a critical habitat. So by doing the two things combined, the rate of mortalities due to shipping strikes actually decreased. But the problem is that fishing gear went up, the amount of fishing gear in the water, and that's why the mortality rates of right whales has continued to increase. So we dealt with one of the problems, but the other problem is now there. We just switched from one to the other.
Essentially still self-regulation. So the shipping industry and the fishing industry do this purely out of their choice. There's no government requirement that they do this.
But there's an awful lot
You
of
could say-
public pressure in the changing of the shipping routes around Stellwagen National,
That's what-
Stellwagen Bank,
Yeah.
and off here, changing of it carries a lot of clout.
It is very complicated. It's not. It takes. Working with the fishing industry is complicated, and changing the regulation, as you probably know, it's going to take time. And the question is, how much time do we have to do all of that? Like doing all these experiments are great, but they're going to take time.
But that's probably the easier part of the problem, because if you the number of ships compared to the number of fishermen, a lot more fishermen than ships. Who has the next one?
Commented that the right whale was right because it would float. And I noticed it does ride higher in the water than the others seem to. So what accounts for that ability?
The thickness of the blubber. The blubber is very thick, and the density is different, so that's why they float.
Thank you. Oh, that was a fascinating lecture. You're a wonderful presenter. I have a question. When you say that once ships know there's 8 to 10 right whales, how is that kind of data being collected? Is that citizen science? Are there apps? Are there trained naturalists, drones? Like, what kind of technology is creating that information available?
It's a little bit of everything. It could be citizens using the app. I have the app in my phone, so if I happen to be in one of the islands and I see a right whales, I send the information to the app. The information is sent to the National Marine Fisheries Services, and they are the ones that create the warning for the ships to slow down. Exactly. So it's all connected. And sorry, I didn't explain that well, but it's all connected. It's part of the same system, warning system. When we do the surveys, we are required to enter our sighting information, including the number of right whales seen, so that they can use that information. It's all very, it's a very well organized system. And I think it works. It really works, at least for that particular area. And the same app has for other species, not just for right whales, but I'm telling you the right whale story because that's the one that I'm most familiar with.
Yeah, because I knew in Northeast Pacific blue whales, there's passive monitoring and there's some drones, there's whale watch companies that take part. So I was just curious how that differs.
Yeah.
Thank you.
Yeah, the thing with the acoustics is that acoustic only, yeah, I think I actually have seen the website. The problem with acoustics is that you only detect presence and absence, not necessarily the number of animals. So this is they only do this when a particular number of animals of right whales is present. And you can't really do that with acoustics.
Other questions or comments? To what extent are satellites being used to track ships here? They certainly are with unregulated IUU fishing, illegal, unregulated, unreported, where they can track ships, and if they're going into protected areas, the government will be notified. And
I'm sorry, you're talking about drones?
Satellites, using satellites.
Satellites, right whales, and ships?
Yes.
I don't think we're
I don't think.
no.
I wonder why. Anybody else have a question or a comment?
What was the name of the app again?
Well app, well alert app. I mean, and it also allows you to take send pictures of the animals. Where is that? Here we go. Oh, well alert app. No, it's for all. We use it mainly for right whales, but you can report in other species as well.
Go ahead, Dave.
So I know in the North Atlantic there's an issue with orca whale and toxicity of blubber and toxins that are building up in the tissues and offloading from milk into babies. And I'm just curious if clearly there's risk of ship strike and entanglement, and probably those are the biggest issues for right whale. But has there been any look into blubber contaminant levels?
Yes, there is someone in our program actually that is looking at contaminants and actually hormone stress levels associated with a lot of these events. So yeah, sorry, I didn't talk about any of that, but yes, it does also has been looked.
Esther, thank you for a fascinating lecture and this very, very important work that you're involved in. We appreciate
You're
it
welcome.
very much.
Thank you so much.
So our next program is on Thursday, the day after tomorrow. We're going to be having the world's premiere of a series of videos that the aquarium has created about aquaculture, and it will be followed by a panel discussion. Now, you know, aquaculture farms, they entrap some animals, but if you compare the entrapment of animals from farms versus wild capture fisheries capture far, far more marine life than farms. Another reason for aquaculture. All right, thank you all for coming.